and start reviewing. I think you would like a taste of statistics here. I've chosen lesson 11-3, page 674. Can we go to 674? And this is a lesson about the normal distribution curve. The normal distribution curve, Matt, is a natural occurring thing in nature. Things normally distribute around the average, with the majority falling close to the average and a few falling far from the average, similar to what it shows in the book here. You can simulate this with a lot of little different things. If you've gone to some museum or something, you may have seen a display with dropping balls or discs or something, and they bounce back and forth left and right. And some of them, the ones that just happen to bounce right every time, get way to one side. If they happen to bounce left every time, they get way to one side. You could do this with stacks of pennies. If you got 1,000 pennies and you decided to flip every penny 8 times, and every time you got a heads, go this way. Every time you got a tails, you move over left a stack, and then on the last flip, you set it down, and you would get, I guess, about 16 stacks, right? And only rarely would you happen to flip heads, 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 and put it on the far stack at the end, you know. Most of them would end up near the middle, and you would get stacks of pennies that look sort of like these pictures on 674. So it's a naturally occurring thing, these distribution curves. Now take a closer look at the slicing up of it on top of 675 there. Notice that the normal distribution curve is kind of divided into slices. They have some symbols there. It's mu right down the middle. The Greek letter mu stands for mean, which is like the average. And then they got one deviation to the right and one deviation to the left. That catches most of the sample. Most of the world is somewhere near the average on normally distributed things anyway. And the little Greek letter sigma stands for a standard deviation. So this is the mu. That stands for mean. This is the sigma. That's a lowercase Greek s, kind of. It's actually the same letter as your big summation symbol, except it's lowercase, sigma. And that stands for standard deviation. So in the normal curve, 68% of the samples, if it's normal, I mean there's a lot of curves that are not normal, but if it's normal, 68% of the population will fall within a standard deviation of the mean. Maybe we should talk a little bit about sigma, the standard deviation. That is found by, the standard deviation is found by adding them all up and finding the mean and finding how far each one is from the mean or average, and adding up all the differences, how far everyone is from the mean, squaring each one's difference separately. Like if we find one here that is 18 away from the average, so then we subtract that to find that 18, square it, add up all those, and then take the square root of the sum, and you'll have standard deviations. It's a little calculation that we're not going to do it, but wouldn't be be that hard with a calculator. The audience is scared.
No.
I'm scared.
Anyway, the standard deviation is a calculation of how spread out the curve is. I think now we should just start doing some of these problems, and I can teach better as we go. So we're going to turn to the first problem here. I'm on page 681. I'll just ask Luke to read that first problem, then I'll tell him how easy it is.
All right. Noise pollution. As part of a noise pollution study, researchers measured the sound level in decibels of a busy city street for 30 days. According to the study, the average noise was 82 decibels with a standard deviation of 6 decibels. Assume that the data are normally distributed.
Do you have any questions?
A is, if a normal conversation is held at about 64 decibels, determine the number of hours during the study that the noise level was this low.
All right, I'd like to ask you to give me back some of the figures that you read there. What did you say the average or mean was?
The average was 82 decibels,
That'd be right in the middle there.
and the standard deviation was 6 decibels.
Okay.
And they did the study for 30 days, if that is anything.
Don't care about that.
Okay.
Then the question was, at what point are we looking at? Normal conversation is
64.
So we're looking at 64, which is a spot, is that 1 deviation below? 2 deviations below? I'm gonna have to try to figure that out. I'm gonna do 82 minus 64. Well, that's 3 deviations under, isn't it?
Yeah.
So that's, looking at the normal curve, let me stay there. Looking at the normal curve, an exact 3 deviations under. I'm checking now on page, top page 677. It looks like if you have 34% within 1 deviation each way, that's 68%, and then another 13.5 and 13.5, and then another 2.35 and another 2.3. Can you add those all up quick for me, Caden? Can you add up, Caden, 34, 13.5, and 2.35?
So you want like both 34 or just one of them?
Well, just double it when you're done, you know.
Whoops. Alright.
He's having a little trouble with that. We can get somebody else, maybe.
99.7.
All right. So 99.7% of the time, the sound will be within 3 decibels, within 3 deviations of 82. It'll usually be within 18 of 82, right?
How did you find that out?
We took 6, we took 64 from 82, and we got 18, so that's 3 deviations. So we say that the z-score is -3. That's this number right here, how many deviations below? Negative because it's below, 3 because it's 3 deviations to the left. So the z-score of a 64 is -3. So they just call that the z-score. And the question is, again, Luke?
Determine the number of hours during the study that the noise level was this low.
Out of 30 days?
Yeah.
Well, we're going to get a percent first. I think we can probably do this on our calculator. On our calculator, we can do a special thing. We have a couple of options. Go to second, distribute.
Nope, it's bars.
What? Well, that's what I meant. Second vars or distribute. And there's a command called inverse norm. Oh, that's on another chapter. Let's choose normal CDF instead. Clear this so that you can get a shot of that. We're going to just go second vars. I'm picking number 2, which is normal CDF. And I would like to know what percent of the time it's below -3. So I'm going to put negative, humongous, comma, -3.
What was the first number?
What was that first number, Mr. Gore?
That was humongous. This command is expecting something like that. Mine does it sideways. Do the newer models have something else there? What does it say? Left and right?
Lower and upper.
Lower and upper? So anyway, what I want to put in there is between what two z values I'm interested. Well, I'm kind of interested in everything to the left of -3. I'm kind of interested in how much curve is right out here. I know it's not much. I know it's a very small amount. So I want to go between way out there and -3. So I'm going to put -3 here. I need a marker that can write. They're the best.
Bang.
So I just put a -100. I don't think it'll be much different than a -10. But I mean, I just went way to the left. That's like a -100 deviations, you understand? It's like, yeah, that's just not going to happen. And what answer did I get there, Eric?
0.00134 and a bunch of other stuff.
All right.
Hey,
So that, I could go like this and make it a 0.134% if I wanted to.
well, on ours it has the
So yours can probably take this and this then. All right, Luke,
Yeah.
how many hours are in 30 days?
Yep, 720.
So you have to take that times 0.0134. What are you getting?
0.97.
So that's a little under an hour then? So, not too often. In my book bag. I guess we better clear up this issue with the other kind of calculator. Jordan,
Yeah,
when you selected normal CDF, you got more than 2 things to put in?
yeah, 4.
4 things?
Lower, upper, and then the, whatever the, so I put in 82 and 6, but when I pasted it, it just gave me 0.
So it had a place to put in this, where of course you put in 82.
Yeah,
It had a place to put in the standard deviation, and you put in 6.
yeah.
Try putting in, for the upper, put a 62 instead, or 64. Maybe yours works differently there.
And what should I do for the lower?
Oh, negative 1,000 or something.
There we go.
All right, so yours is, so for yours, you have to put in more things, but it's kind of nicer because you didn't have to do this, you see. Ready to do another one?
So this one is 97.
Well, they asked for how many hours, and we got 0.97 hours.
Oh, okay.
And is there a B? Oh, there's a B. Determine the percent of the study during which it was between 76 and 88. So Jordan's kind of calculator is going to put 76 and 88 right here. My calculator, which is 83.
Yep.
I think some 84s do the same thing. My kind of calculator, I have to do 88. You're gonna help me with this, Luke? I don't know, these are nice numbers. 88 is a z-score of 1. It's just 1 deviation above. And 76, I guess I don't need your help, because it came out nice and neat between a -1 and a +1 z-score. So my calculator is just going to put in -1 to 1. Can I ask Luke what he gets when he calculates the 76 to 88. Percent.
0.68.
Alright, so that means 68% is the answer to 1B. 1B.
Okay. 76 and,
Jumping down to number 3, I'm going to use Jaden. You have your calculator, Jaden?
It's kind of a weird one. I have the TI Inspire, so I don't know if that's the best idea.
Oh, well, have you had any success yet?
I finally found normal CDF, so that's kind of the thing.
And for yours, do you put in Z scores or do you put in original scores?
I put in the ones like Ben and Jordan have.
All right, that's fine. So now we're going down, Jaden, to number 3. And it's a totally new distribution. We want to find the z-score if x is 19 and the average is 22. So I'm going to change this all up now, Jaden. They said the mean is 22.
Yep.
Yeah, so I'm putting a 22 for my middle here. And X means this particular score is 19. And it says that the standard deviation is 2.6. So what you have to do for me, Jaden, is figure out this 19. I want to see how many deviations that is below. So you're going to go 22 minus 19, like so. That's a 3, of course. And you have to tell me how many 2.6s that is. In other words, divide that by 2.6.
1.15385.
So that means the distance across here is 1.15 of those deviations, right? So then the z-score, since it's left, is going to be negative 1.15. And that's all they asked for in number 3, the z-score. So that'll work the same on all our calculators, I think. The z-score is just asking at what standard deviation is it? How many deviations is it from center? If it's left, it's negative, right? Let's do another one like maybe 4, because 4 they turned it around. 4 they say the average is 64. Help me here, Mitch.
Okay.
Not yet. They said the average is what, Mitch?
64.
64. What else did they give you?
Is it called deviation?
Yeah.
1.3.
Standard deviation is how much?
1.3.
Okay, every 1.3 is another z-click then. And then what did they want? Oh, did they tell you another thing?
They told you Z.
What is z?
2.3.
So z is talking about a spot that's they're talking about a spot 2.3 deviations to the right. So it's going to go da, da. It's like way over here. And they want to know where you are, I suppose. It's going to be 2.3 of these, Mitch. So can you do the 2.3 times 1.3?
2.99.
So that's 2.99 to the right of this. So I think we're talking about 66.99 will be the spot that they're talking about. That's the X they are asking for, 66.99. Answer books say 66.99. Alright, I would like to jump to number 11 now. We'll look at that a little bit there, Matt. Looking at number 11. It's still going to be talking about a normal curve. Have you figured out what they're asking for?
Not yet.
What does it say? Number 11. Well, Matt, if we go from here to here, that's the middle 68% of the population, you know? They want to narrow it down to the middle 11%. Is that right? No, it's number 11. Middle 30%. So they want like 15% there, 15% there. So they want to know between what z-scores that happens. Grab the calculator. Instead of a normal CDF, we are now going backwards, kind of. And there it is. Grab a calculator, go to distribute again. And you see number 3, the inverse norm? Inverse norm is kind of for doing it backwards. And it's asking you how much do you want to be left of the line. I kind of want to find this line here. If I find this line, I think I can find this line, you know. So I want to know where this line is. I think it's at about a negative half a deviation, you know. But I want to know what percent of the world do I want to the left of the line. The number that I put in right now is the percent of the population that has to end up here. If I would put in a 50, it would just say, well, that's the z-score of 0. So I got to put in a little less than 50, like about 35, don't I? If I put in a 35, then it'll tell me at what z-score 35% is to the left. If 35% is to the left, that mark will be symmetrical, and I'll have the other one too. So we're going to go put in a 35%, which I think has got to be a 0.35. My calculator says that's a negative 0.385. So since I put in a 0.35, I figured 35% is over here, 35% is over here, and the rest is in between here, and that would be the middle 30%.
Is the 0.35 the area?
The 0.35 is a percent of the population.
Well, like when we're putting in our calculator, how do we put it in?
Oh, yours is asking for an area?
Yeah, that's the area, and then the two symbols you have up there too.
Oh, so you have to go all the way. I don't know, you might need to find a different command.
Okay.
Oh, you know, inverse normal will though.
No.
Inverse norm wants all those things. All right, then put the center as 0 and the standard deviation as 1 and see what happens once then.
And the area is 0.35.
Yeah.
Alright, negative 3.8 is your grade.
You got this?
0.3. Yeah.
All right, so that's the way you would run that then.
Okay, thank you.
Good question.
So that would be, on the one side,
Oh,
there's
you just-
0.35 is both sides out.
I think you're far enough now, you can start doing some problems.
Are you doing outside?
Yeah, what's the difference between the middle and the outside?
Oh, all right. Like a number 15?
Yeah.
Doing a number 15, we want outside 25%. Which would mean inside is, all right. Now, outside 25%, I think they mean like 12.5 over there and over here. Is that right? That's the way I'm taking that. Outside 25% means not the center 75%. If you're in the outside 25%, there's 12.5% over here that we're not talking about. And we want to exclude 12.5% here. So I think all I have to do is my inverse norm command. Just wants to know what percent to the left. It will give me a line that has a percent to the left. I think I'm going to put 0.125 there. And then it will give me the correct z-score for that. What does it give you?
1.15?
What was that?
1.15?
Negative?
Negative.
Yeah. Now watch what happens if you decide you want to find this line. Lou, what percent of the population is to the left of this line?
That would be 87.5.
Nice. Put in a 0.875 here once.
Who knew?
I was really hoping for that. All right, so you can pick whichever line it's easier for you to find the percent for. But the percent to the left is what it's asking for here, and it gives you the z-score of that spot. Think we're ready to wrap the lesson and go to work?
Yeah.
Wrap it, Eric.